Hey guys, my name is Trevor Sullivan, and welcome back to the Stratus Grid YouTube channel. I'm a solutions architect on the Stratus Grid sales team, and in this particular video, I wanted to explore with you how you can query data from an Amazon DynamoDB table using the AWS SDK for Rust. Now, before we get started, if you're interested in working with Stratus Grid, feel free to go out to stratusgrid.com, hit the Let's Talk button here, and you can explore some of the different solutions we have around migrating to the cloud, cost optimization in the cloud, modernization of existing software solutions that you might be running into containers or serverless based applications, and a whole bunch of other custom software development services. So feel free to hit this button on our website and reach out to us, and we'd love to talk to you about your particular project. Now, for this video, we are going to be talking about, as I mentioned, querying data from Amazon DynamoDB. Now, if you watched our earlier video on DynamoDB with the Rust SDK for AWS, you'd probably know that we talked about building a product catalog. And when I say a product catalog, it's not some grandiose product catalog. It's actually a very simple product catalog, but we're just demonstrating how to create a DynamoDB table with Rust, as well as how to insert items into a DynamoDB table as well. So now that we've covered that in this particular video here, it's about an hour long. So feel free to check out that video, and then you can come back to this video and actually learn about querying data from that DynamoDB table. So we've already got this table over here in AWS. So I'm in the Northern California region here. I'm in the DynamoDB service in the AWS Management Console. And if we head down to tables here, you can see that I've got this Stratus Grid products table right here. And you can just click on Explore Table Items right here. And this is going to allow you to play around with the two different types of data retrieval in the DynamoDB service. So we have the ability to do something known as a table scan, as well as a query operation. The table scan operation is less efficient than the query because it actually has to it has to query all the different items within a DynamoDB table. And that can take a very long time, especially if you have a very large DynamoDB table. Imagine that you've got maybe millions or tens of millions of items or documents inside of your DynamoDB table. That can be a very storage intensive operation, as well as network intensive, because it has to retrieve all that data from DynamoDB storage and then actually send it across the network back to your Rust application. So we're going to skip over table scans for now, since that is kind of a less efficient approach, and it's only useful in certain circumstances where you need to look at all documents in the table. And we're actually going to be focusing on the query operation here. So the query operation is going to allow us to retrieve records or items from our DynamoDB table based upon the partition as well as the range of particular attributes. So when we are running a query operation here, we actually have to specify a value for our partition key. Let me just do a really quick scan operation here, and you'll see that right now we have 6 documents or 6 items inside of our DynamoDB products table. Right now, our hash key, our partition key, is the category field right here, or attribute, I should say. And we have 2 different partitions based on 2 different partition values that we have. So we have living room. So these 2 items right here belong to a particular partition. And then we have 4 items that are part of the kitchen category here. So those belong to a different partition. And by partitioning your data, you're basically helping the DynamoDB storage service on the back end. It's all completely opaque to you, so you don't have to worry about the actual storage service. But by partitioning your data, you can help the DynamoDB service to optimize your storage and divide it up across many different partitions on the actual servers behind the scenes that are running your DynamoDB table. And that helps to balance the load of activity across your entire DynamoDB table. So what we're going to be doing is actually running a query here. Just for starters, you can use the AWS Management Console to kind of play around with queries and understand how they work. But then we're actually going to go back to our Rust code over here that we started writing before, where we create a table with a partition and a sort key. And we also took a look at how to do a loop down here to interactively prompt the user to enter data for all the different attributes that we want to enter into a new document or item into our Dynamo table. So that's how we actually got this data populated into our table in the first place. But now we're going to kind of segment or refactor that code into separate functions so that we don't have to recreate the table every time we run our code, and we don't have to insert items every single time that we run our code. We're going to put those into separate functions, and then we're going to write a new function that allows us to actually query this data using this query feature rather than scanning. So really quickly here, what we're going to do is say that I want to go to the category, which is my partition key. And we want to say, I want all of the kitchen items, right? So if I plug in a value of kitchen for the partition key, which is the category attribute, then when I run that query, you're going to see that only 4 items are returned because I only have 4 items that belong to the kitchen partition within the category attribute here. Now, similarly, I could do something like bathroom here. And when the query runs here, you're going to see that we don't get any items returned. So the query technically succeeded because we were asking the service to return a category of bathroom, but we simply don't have any documents or items that match that particular query. So we don't have a partition with any bathroom values, so it's not going to return anything. But we can change this over to something like living-room, which we know we do have a couple of items for. And sure enough, down here, you can see that we've got our couch TV, and we've also got this price attribute here. Now, something else that's interesting to note when you are running queries against a DynamoDB table is that you have really 2 different mechanisms in order to filter data that's being returned back to your Rust application. So the first thing is absolutely mandatory. We have to specify a partition here. You can't write a query that spans multiple partitions. In fact, if you go check out the documentation here for the DynamoDB service, if we drill down under the working with DynamoDB and then take a look at read and write operations, take a look at the DynamoDB API. You can ignore this particle language for now. That's kind of a SQL-like syntax that you can use to work with DynamoDB, but we're just going to focus on the core API for now. And then go under working with item collections and take a look at working with queries. And it tells you right here that you must provide the name of the partition key attribute, which in our case is category. When we created the table, we specified that the category attribute was going to be the partition key, and we must specify a single value for that attribute. So we specify living room, or in a separate query, we specify kitchen, or in a separate query, we specify bathroom or bedroom or whatever category of products that we want to target. Maybe we have a grocery category. Maybe we have an auto parts category. So we have to specify that partition key so that when we send that query to the DynamoDB REST API, the DynamoDB service knows exactly which partition we are attempting to retrieve data from. So that is the first mechanism that you have in order to filter data from your DynamoDB queries. Now you can also specify a range as well. So when we specify what's known as a key condition expression, this is where we specify the partition key name and a value. So that's specifying which partition we're going to retrieve data from. However, we can optionally specify a second condition, and this is based on the range or sort key. That's the same terminology there. Sort and range key are referring to the same thing. But if you recall, we actually used something like the name, I believe, as our secondary sort and range key, so we could specify that, but we can also filter data. So we can actually filter data based on other attributes that belong to our document beyond just the partition and the sort key. So we can actually add an additional filter. It's better to specify things in the actual query under the key condition expression, because that's going to limit the data that's actually being retrieved from the underlying storage. But if you do retrieve a larger data set and you can't filter your data based off of either the partition or the sort key, then we can do something known as a filter expression. So let's go back to the console here really quick and take a look at an example. I'm going to grab the kitchen data again here so you can see these documents. As you can see for the kitchen partition here, we have a bunch of different prices, right? And the price is just an extra attribute. That is not the partition key. It is not the sort key, because category is our partition key. Product name is our sort key, but we can't really sort or do a range across a string value like this. But let's say that we wanted to get all products that cost, let's say, less than $6. So in this case, we have 1, 2, 3 items in our table that cost less than $6. We only have one, which is the fork here, that costs more than $6 at $6.30. So we can actually specify an additional filter that is not based off of the attributes that are the partition or the sort key. So the price is just an extra attribute that we've added to each document. There's no mandatory schema in place that says every single document has to have a price attribute, right? We just added that out of simple standardization for the data format that we chose to use for our product catalog. But the filter expression here allows you to refine your results after the underlying data has been retrieved from the table, and then you can do a further filtration on the server side, and then finally the data gets returned back to your application. So filters are great because it does the filtration on the server side. It does it after data retrieval, but it still does the filter on the server side before it sends the data back to your application, and that ultimately reduces the amount of network bandwidth that's being consumed for your application to grab data from the table. Now, you can also do client-side filtering in your application as well. So if you just want to grab all the data from a partition and then just filter that data on your app inside of your application code, that's another option as well. However, you are going to be potentially wasting network bandwidth in that case, and you're also not taking advantage of the range or sort key that you can do additional filtration on in the key condition expression here. So again, it's best practice to use the key condition expression if possible to retrieve from a specific partition, and then specify an optional condition for your range as well, where you can specify that maybe a specific product name or specify a particular range of values. If you do have something like price as being your secondary sort or range key, then you can actually say, I want this value to be between X and Y values. But if you don't have a range key set that is appropriate for these particular operators, then you can always use the filter expressions. And then finally, the third best option is to do the client-side data filtration. Now, there's other interesting things that you can do. So with items, when you are retrieving items from a DynamoDB table, you have the ability to do something known as a projection expression. So this is where we can specify which attributes we actually want to retrieve from the underlying items in the DynamoDB table. Now, this is actually reflected in the AWS Management Console right over here. So when we do a query operation, we can specify which partition we're querying, right? That's mandatory. But over here, we've got the attribute projection. And so what we can do is say, I want all attributes. That's just the default, where it's going to give us all of the attributes that we've defined on our documents. So we have category, product name, and price. Just by convention, we could have additional attributes if we inserted items with those attributes, but we can also say, I want specific attributes. So maybe I already know what partition I'm querying from because I had to feed that partition as a value into the query when I ran it, right? So if I wanted to, I could simply skip over retrieving the category and actually cut down the amount of data that's being returned from the query, since I already know the partition key that I am querying. So what we can do is say, well, I only want to get the product name, and then I also want to get, let's say, the price here as well. So now I'm just leaving off the category again because I already know which category I'm querying because I'm the one that has to specify that in the query. So now when we run this, you're going to see that we get back the product name and the price attributes here, but we've completely omitted the category. So that feature that allows us to limit which attributes are being returned from the query is called a projection expression in DynamoDB terminology. I know it's kind of a fancy term and it might sound kind of intimidating if you're not familiar with the lingo within the DynamoDB service, but all a projection expression is allowing us to limit the data or the attributes that are being returned. There are some slightly more advanced features where you can actually go deeper into a specific attribute, like a map value or a list value, which is kind of like an array, and you can actually retrieve specific values from those maps or list items. But for now, just think of it as a way to limit which attributes are being returned. And feel free to check out the documentation for projection expressions to learn how to retrieve individual items from maps and lists as well. All right, so I think that's enough about DynamoDB for now. One other thing that you'll want to familiarize yourself with as you start working with queries in DynamoDB is how to actually iterate over the results that you get back from the query and actually extract the individual key value pairs, right? So when I run a query, like the query that we just ran right over here, let's say I get this result set here. And so I now need to iterate over each attribute and say, okay, for document number 1, I need to get a list of all the attributes. Maybe it has 5 attributes. Maybe it has 10 attributes. I don't really know, but I can simply iterate over the key value pairs in that document and say, oh, it's got a product name and that's a cup. It's got a price. That's, this value right here, and so on and so forth. So we're going to take a look at how to actually retrieve those attribute values and then determine what data types they actually have, because you've got, strings, you've got number values, you've got binary values, you've got string sets, you've got lists, you've got maps. And so there's a whole bunch of different data types that you might potentially need to decode these attributes as and actually get the values of those underlying attributes. All right, so I think that's enough about queries. Let's start with just the really most basic operation, which is going to be to specify that we want all attributes. That's just the default. And then all we're going to do is specify the category, which is in this case our partition key that we want to query data from. So what we're going to do over here in our Rust application, you can see that from lines about 13 right here, all the way up through line 48, this is all code pertaining to creating a DynamoDB table. So we specify our attributes. We specify that one attribute is the hash key or partition key. We specify that the other attribute product name is our range or sort key. And then finally, we call the create table operation here. We pass in all of our different settings for the table creation. And then finally, we send that. And then we just check the result to see if it was created or not. But we don't want to necessarily recreate this every single time. So what I'm going to do is just cut this out right here. And we're going to create another async function. So I'm basically just refactoring at this point. I'll do a function here called create DDB table. And we'll just paste all this code in right here, but we're going to need to pass in a couple of arguments into the function. As you can see, we get errors right here because table name is not a local variable in the scope of this new function. So we need to pass that in. We also need to pass in the DynamoDB client that we create in the main function up here, because that is how we are interacting with the Dynamo service. So we only want to create the client once based on our credentials that we're loading from environment variables, and we'll just pass a reference to that client so that we can borrow it from our child function here. So I'm just going to create a parameter here called DDB client, and we'll make that a pointer to the Dynamo client over here. So that's going to be a client object. Let's do ampersand client. And then we also want to add the table name, and we'll make that a string value as input. And then up here, when we actually call this function, I'm going to comment it out just so that we're not actually calling it. But then we're going to pass in the table name dot toString right here. And now this function should be just fine. So yeah, down here on table name, that is resolving just fine. And then the DDB client here, I'm just using the same argument name as the variable name up here, so that resolves as well. And then because this is an async function, we also need to await it so that our other async operations like this one right here that are being awaited are also going to get executed properly. If you don't await a future, that function is never actually going to execute. In Rust, you actually have to have an async executor that is actually driving it to completion, the future to completion. So if you don't await, then as you can see from this warning right here, it's just going to say, you're creating a future, you're kind of scheduling this work on a queue, but you're never actually telling it to run, right? So when we do await, that'll cause it to run in a blocking fashion right here. So I'm going to go ahead and comment that out because we don't want to recreate the table every single time. And then the other thing that we're going to do is take this loop. We're going to refactor this into an async function, and we'll say insert item loop, and we'll do no arguments there for now. And so now we're just going to have a looping construct in this function. And then once again, we need to pass in the Dynamo client as well as the table name right here. So let's go ahead and pass in these arguments just like what we have right down here and pass those in. And I can take off the toString here because table name should already be a string. Actually, it looks like it's getting moved. So let's go ahead and clone it here. And I think that's because I'm using it in some other location here. All right. So now that we've got that, let's go ahead and just invoke the insert item loop. All right, do that. And then we are going to do table name.toString right there. And then we also need to await this. So now we could run our Rust program here. Let's do a cargo run. It's going to skip over the table creation because we commented out that function call that we extracted into a separate function, but it is still going to allow us to enter new data. So let's do something like bathroom, and then I'll do a faucet. How about let's do faucet dash silver, and let's do a price of how about $55.70. And we can just hit Q to skip over the next item there. So now we'll just go back here and verify. If we do a bathroom query against the category, we should now have a single item. So now let's do a quick table scan. And we now have 3 partitions. We've got living room, we've got kitchen, and we've got bathroom. Great. So our Rust code has been refactored here. This makes our main function a lot cleaner here. I'm going to go ahead and comment out the insert item loop. And now we're going to focus on the query operations. Now that we've refactored things, cleaned everything up a little bit here, we're going to write another function. Going to be async because we're doing async operations against the AWS SDK for Rust. And I'm going to say query DDB table. You can name the function whatever you want to. I'm just going to call it query DDB table. We're going to pass in our Dynamo client because we're going to need that as well. We also want to pass in our table name because we're going to need the table name that we are querying. And of course, that's defined in a variable right up here in our main function. So now what we want to do is actually write a query operation. And what you can do is reference the documentation for the DynamoDB crate. So let's go to docs.rs in your browser, and we'll say DynamoDB in the search here. We are looking for AWS SDK DynamoDB. We're going to go down to modules. We're going to take a look at the different operations that are available. So these are all the functions that we can call on the DynamoDB client itself. We're going to go down under the query module right here. And then you're going to see that we have the builder here that allows us to build a query. Now, the way that we get this builder is to call the query function on the DynamoDB client. So let's do DDB client dot, and then we'll say query. That should give us a builder. Let's say let query op equal the query here. So now we've got this query fluent builder, and now we can specify all of the different input arguments using these function calls here. Now, typically you can skip over all the get and all the set functions here. Typically what you're going to want to do is look for things like key condition expression right here. You can also specify things like limit, if you want to limit the number of items that are returned in a particular result. If you want to specify a filter, you can specify query filter here. And so generally, we're just going to be skipping over get and set functions, and we're going to be looking for the actual function names that allow us to specify our input arguments. So the first thing that we're going to want to do is specify the table name here. So in our query function, we are just going to say dot table name, and we're going to pass in the table name variable or argument that we're passing into the function right here. And then once we specify the table name, remember that we need to specify one of these key condition expressions. So back under working with item collections, take a look at key condition expressions here. We have to specify, at a bare minimum, a key condition expression, which looks kind of like this, where we say category equals, and then you have this weird syntax here where you've got a colon preceding it's kind of like a variable name. But then what we actually do is we specify these expression attribute values. And what we do is we basically map this placeholder. So Amazon DynamoDB is going to be basically substituted where colon name is. So this is basically a syntax. It's very unique to DynamoDB here, but what we're doing is basically populating this name placeholder with the actual text, the actual string text. The S there in DynamoDB stands for string value as opposed to numeric value or string set. String set would be SS, or a map value would be, I think, an M, and things like that. So we know that this is a S string value, and this is the actual string that would be substituted for this placeholder right here. I'm not sure why they chose this particular syntax. It's kind of confusing. It doesn't really follow a lot of other conventions that I've seen in my 2-decade career, but it is how it works. So we need to specify the table name. We've already done that. And this is just the syntax for the CLI, so we kind of have to translate it to Rust. Then we specify our key condition expression, where we say our partition key, which is category, equals a particular value. And then how do we specify what that value is? By using expression attribute values. Back over here in the documentation for the query, if we say expression attribute values, we can specify a key value pair that we want to pass in as a substitute for that placeholder that you have right here. Now you can call this placeholder whatever you want to. This one just happens to call the variable name, but we could call it category or product category, whatever you want to, as long as these two values actually match up so that the substitution takes place correctly. All right, so back in our code, we are going to specify the dot, and then we're going to say expression. We want a key condition expression right here. And our key condition expression is just going to be a string. So what we're going to say is that the category attribute, again, this is going to be whatever your partition key is. So right here in our list of tables, we've got StratusGrid products. You can see our partition key is category. So that's what we need to specify for the key condition expression. So category equals, and then we could say the value. And then once we add an expression attribute value, that'll get substituted for this little placeholder here that's prefixed with the colon. So now, after we specify what the partition expression is here, we're saying I want the category, which is my partition key, to equal a specific value. Could be kitchen, could be bathroom, could be living room. It could even be a non-existent value, as we saw when we were experimenting with the AWS Management Console earlier. So now we'll say expression attribute values. We just specify the key, which is going to be this placeholder right here. So you can literally just copy that and paste it in there. And then the value is going to be an attribute value, which is a special type under the DynamoDB SDK types module. And there's a type called the attribute value here. I think it's an enumeration. And then what we can do is say it's going to be a string value. And the string that we want to match against could be about kitchen. All right, so we'll say kitchen, and then that needs to be a capital S string. So we'll take kitchen and turn it into a capital S string rather than a static string in Rust, which is the default when you specify double quotes. So now you can see that everything is resolving here. So finally, we can do a send dot await, and that should run the query operation. Now, as is typical with any type of operation that you have in the AWS SDK for Rust, you are going to get it wrapped in a result here. So the result type is a very common pattern that you see in Rust, where you get some kind of result back from a remote API. It could either be successful or have an error state. And so the result here allows us to either see the query output if it's successful, or if there's an error, then we get back this SDK error type. So what we'll do down here is say if the query op, which is our result, dot is okay. This is just a standard function that you see on the result type. Then we're going to say print line query was successful. Now we're not going to retrieve the actual individual attributes from the documents or items right now. We're just going to say if it was successful, print out this text. Otherwise, go ahead and just print out some text saying that there was an error. So error occurred during query operation. And then the other thing I'm going to print out down here is going to be the debug output. So we'll do :pound ? And then we're going to pass in query op dot error, and that'll actually retrieve the underlying error and print it out in a pretty kind of readable format that's basically looks like JSON, but it's pretty printed so that it's very easily readable inside of our terminal. And with that specific error message, we can see what problem actually occurred. So what we're going to do now is just say cargo run and see what we get back. All right, so it looks like our program ran here, but of course we never actually called our function here, query DDB table from main. So it skipped over creating the table and inserting items. So we just need to call query DDB table and say dot await. And we also need to specify the table name as a string value. We'll turn it into a string using the toString function right there. So now let's do cargo run, now that we're actually calling our query function this time. And as you can see, our query was successful because we specified all of the necessary inputs to the query operation. Now, we could have a bunch of different things go wrong. For example, right here, we've got category, that's our partition key. But if we specify the incorrect partition key, like let's say maybe I try product underscore category. Well, that's not the partition key. We can actually very clearly see on the table configuration that the category attribute on each item is the partition key. So there is no product category partition key. So if we were to try to run this, we'll probably get some kind of error here. Sure enough, it does say that our query condition is missing a schema element of category. So it's actually very specifically telling us which element of our query is missing. And so as soon as we fix that partition key to category, things should work perfectly fine. Now, remember that I mentioned that there's secondary criteria. So we have not specified any additional criteria on the key condition expression relating to the sort or range key. And that's because our sort key is actually a string value here where it's product name. But if we take a look at the key condition expressions here, we can specify a second condition for the sort key if you specify a sort key. Remember that when you create a DynamoDB table, you don't actually have to specify a sort key if you don't want to. You can literally just have a partition key, and any other attribute that you define on your individual items is entirely optional. So what we could do is say that I want to specify my sort key as an equality. So remember that with the partition, it must be an equality condition. So you don't have the ability to say greater than, less than, or between, or anything like that. But when you're using the sort key, you can use these additional comparison operators to determine which specific values you want to retrieve from that partition, right? So you're scoped to a specific partition, but then we're saying within that particular partition, I want to grab just a certain range of items. And this would be a lot more appropriate if we had something like, a numeric value where we could say if it's greater than $5 or less than $10. But because the price is actually a separate attribute, it's not part of our sort key, we would have to do that in a filter operation after we retrieve the data. But just for the sake of demonstration, let's go ahead and do an additional query here. Before we actually do that, I do want to show you how we can get the number of items. So let's just do another print line statement here and say there were X number of items retrieved from the partition. And then what we're going to do is pass in query op dot unwrap. We have to unwrap it from the result. And then we're going to say, what are the count of items that were returned? So let's do another cargo run operation here. And for the kitchen partition, we should have 4 items. But if we change the value that we're feeding in to, let's say, living room, and of course you could prompt the user for this. I'm just hard coding this for now for the sake of example. But if we do a cargo run now with living room, we should have, I think, 2 items. So yeah, sure enough, it says there's 2 items. And then if we say, bathroom, then it should say that there's 1 item because we only inserted a faucet item. All right, so that's telling us how many items were retrieved from the query. But let's go back to, let's actually do living room. And then what we're going to do up here is say that we also want to specify an equality operator for the sort key. So I want to retrieve a specific item based on its name. So for living room, for example, we'd have a couch or TV. I think those are the 2 different objects that we have defined, or the different items that we've defined in there. Yep, so living room couch or living room TV. So either of those values should work perfectly fine. So what we want to do for the secondary filter here is say and, so that's a special keyword, and then we can specify that the product name attribute right here should be equal to, how about, couch? And then that'll grab a very specific item from our table. So in our key condition expression here, we've got category and product name equals the product. And then we're going to specify another placeholder here. So we're going to call this function again. I'm just going to duplicate this function right here and say expression attribute values and say the product. We're creating 2 different placeholders here, and we're going to say that the product is going to be a couch. So that's getting a very specific item. So we should only ever have 1 item returned, even though we have 2 items in the living room partition in our DynamoDB table. We should only get a single result from this query. Sure enough, there is just 1. So if we revert those changes, we can just comment out the couch criteria right there. Then we can remove this secondary filter right there for the range key. And then because we're only grabbing the partition, we get back our 2 living room items. So that's how you can combine the criteria for the partition key and the sort key as well in the same key condition expression. All right, so we're going to just grab all of the values from, or all of the items from a partition. So I'm just going to get rid of that expression attribute value, substituting for the partition, or the range key, sort key, I should say. And then down here, the other thing that we want to do is do a client-side filtration, or actually a server-side filtration, but after data retrieval. So what we're going to do is say dot filter expression. And then once again, very similar to the key condition expression up here, we can specify additional attributes. But this time we are not limited to filtering on just the partition or the sort key. We can actually filter on arbitrary attributes in each document, because again, with a NoSQL key value data store like DynamoDB, we don't have to have a predefined schema for every single item. Some items might have a price, some items might not have a price. Some items might have a listed vendor attribute, some items might not have a listed vendor attribute, right? So it's really up to you how you want to kind of organize your data in a Dynamo table. But using the filter expression here, we can do something like price is between value 1. So we can call this maybe lower bound, and let's say upper bound as well. And so what we're going to do is take a look at the between operation here. So between X and Y. And so what we're going to do is substitute a couple more values, but this time we are doing a comparison on price. And remember that price is actually a numeric value. It's not going to be a string value. So what we're going to do is add another expression attribute value. But the difference this time is that the attribute value is not going to be an S string, it's actually going to be a numeric value. We still specify the numeric value as a string, but when we wrap the attribute value in an N number type, then the API actually knows how to turn that string into a numeric value when it injects it into this filter expression for DynamoDB. So we're going to say lower bound, and then we're going to say attribute value. And then this time we want a number. So it's going to be an N type. And then as you can see, we still have to specify a string as input here. So we're going to say that the lower bound is going to be about 3.0 dot toString. And then we're going to duplicate that down and change lower bound to upper bound. So we're passing in 2 different placeholders right here for the filter expression. And I'm going to say that the upper bound is how about 5.5. So any products that are greater than 3.0 as far as price goes, and the price is less than 5.5, then those are going to be included in the query. So really quickly, back in our items list here, let's do kitchen here since we have a few more items in the kitchen partition. So we've got 2.4, so that's going to be less than 3.0, so that's not going to be included. We've got 5.6, that's greater than 5.5, that's not going to be included. We've got 4.75, so that's between 3 and 5.5, right in the middle, basically. And so that should be included. And then finally, the fork should not be included because that's greater than 5.5. So let's actually bump this up to 5.7. And that should include the knife. So we should get back a plate and a knife document. So we should have 2 results in this query here. So now we're doing a filter. So this is after we retrieve the data from the partition right up here. So we start by querying the partition. That's mandatory. Then we add the optional filter expression after all those documents have been retrieved from storage. Still on the server side, we are going to do an additional filtration. And that's going to filter based on the price attribute right here for each document and return the results. Let's do a cargo run here, and we should get back 2 items in our result. Sure enough, there we go. Then if we wanted to change this and say, let's include things all the way up to $7, right? So that should include the fork. That's 1 extra item, so that should give us 3 items in our results. So we'll say 7.0 as our upper bound. And sure enough, now we have 3 items being returned. All right, so that is all working perfectly fine. We've done partition queries based on a specific singular value, scalar value for our partition. We also saw how to use the range key to do an additional key condition expression on the storage engine side of things. We took a look at how to do server-side filtration with the filter expression here. And I think the last thing I wanted to cover is basically once we get these results, right? Once we do a partition query or do a partition with a range key query, or if we do a server-side filtration operation after data retrieval, how do we actually iterate over each of the attributes in the query? So right now, remember that with projection expressions, the default is to return all attributes of each item in the DynamoDB table. So every single result that we get is going to have a category, product name, price, and any other attributes that those documents might have in the future. If we either update those documents or add new items that have new attributes associated with them as well. So what we're going to do is just say if the operation is okay, then I'm going to comment this out right here. And what we're going to do is say for the DDB item in the queryOp.unwrap.items. All right, so what we're doing here is we're calling this items function, and that's going to return a hash map. And this hash map is going to allow us to iterate over all of the items that are being returned here. So the hash map is going to have a key and value pair for all of the attributes in each document. So we're going to start by iterating over the item, but then once we get the item, we need to iterate over all the attributes for the item, right? So what we're going to say is for DDB adder, I'm just going to abbreviate attribute here, in the DDB item dot keys, Another thing that we could do here is actually say ddb item.iter, and that'll actually give us a tuple type here, which will give us the 0th item, or the first item is going to be the key as a string, and then the second is going to be the attribute value. That's another way that you can do it. Or you could say iterate over the keys here, and then you could say ddb item.get, and then get a particular value based on the key name. But I kind of like doing it using the iter approach right here, because that'll give us the tuple type here, and we have access to the key and the underlying value. So what we're going to do is just print line here and say, I want the product name and the product price. So what we're going to do is go ahead and just specify that we want to print out the string value. So that's going to be ddb adder.0. That's how we specify the first element of a tuple type here. And then we also want to specify the ddb adder.1. That's going to retrieve the second element from the tuple, which is the actual attribute value. And then we need to interpret it as a particular data type. So there's all these helper functions here that allow us to specify which type we want to actually convert the attribute value to. And so what we can do is to try turning it into a string value. But in the case of the price is actually going to be a numeric value. And so it's going to fail when we attempt to extract it as a string. So this is going to give us a result type. So we need to unwrap that. And so what this is going to do is iterate over each attribute that's returned. So we've got category, product name, price for each item, and it's just going to print all that data out to our terminal. So let's do a cargo run here. We're probably going to get an error after it prints out a couple of lines here. So it says query was successful. And in this case, you can see that we cannot unwrap the numeric value here because we are interpreting that numeric value as a string. So if that fails for some reason, then what we can say is, or we can try to retrieve it as a different value. So we could say ddb adder.1.as n for a numeric value, and then unwrap that as well. So with the price, because the price is a numeric attribute, it's going to just fail when we try to retrieve a price numeric value as a string. But if it is a string, it'll just go ahead and unwrap it. But if the string unwrapping fails, we can try it as a numeric value. We could add additional OR statements here as well to interpret other data types as well. It's really just up to you as far as which data types for DynamoDB you're actually using in your DynamoDB table. So now you can see down here, our query output is showing us the price, product name, and category for the first item. We've got product name, price, and category for the second item, and category, price, and product name for the third item. What you're going to notice here is that the attributes are being printed out in a non-deterministic fashion. So this first item here was returned with the price coming first. The second one had the price in the middle, and same with the last one here. So the category actually came first on the last one, the price came second, and then the product name came in third. So it is non-deterministic here, which is one reason that you might want to iterate over the keys and then retrieve specific values from those keys rather than just iterating over every single key and value pair. But if you're just writing out just the raw data right here, using this iter method here to grab a tuple is a pretty nice way to accomplish it. All right, so what you're noticing here is that, again, the default projection expression is to retrieve every single attribute from every single document. Now, back under not working with items collections, but if we take a look at working with items here, which is under DynamoDB API, working with read and write operations, working with DynamoDB, which is at the root of the DynamoDB developer docs. If we go to projection expressions right here, all we need to do is specify a single attribute or a comma-separated list of multiple attributes that we want to retrieve. As I mentioned earlier in this video, there is a way to actually reach into an array and grab specific elements from that array, also known as a list in DynamoDB. And then we also have the ability to specify in a map type, which is a set of key value pairs, as a child of an attribute. So I could have an attribute that has details, and details could point to a map, and then that map could have vendor equals X, or product name equals Y. And so I could actually embed all those details underneath of an embedded attribute called a map as well. So if you want to retrieve an attribute from an attribute, so you have an attribute called product reviews on an item, and then under that map, you have a key called 5-star. Either maybe it's a true or false kind of binary value. You could retrieve that as well. We don't have any advanced data types like lists or maps, so we're just dealing with scalar values. So what I'm going to do, remember how when we talked about projection expressions earlier, we already know when we run this query which partition we are querying, either by hard coding it into our application, which obviously isn't a great idea, or based on some kind of user input. It could be in a web application, it could be in a CLI application where we prompt the user to type the partition that they want to query from the DynamoDB table. Of course, you probably wouldn't phrase it like that. You'd say, which product category do you want to retrieve items for? And you could say kitchen or living room or things like that. But once we retrieve that partition, we already know what the partition key is. So we don't really need to return the category because we already know what the category is, right? So if we're retrieving, let's say 5,000 objects or 5,000 items from DynamoDB, we don't need to return the category attribute with every single one of those items. That's just wasting network bandwidth, and it's not giving us any additional value. So one of the optimization things that you can do from a performance perspective is to do a projection expression and limit the results to only including the price and the product name, since we already can infer the category based upon the partition that's being queried. So this is really easy to add into our application. It's just another argument that we pass in right here in Rust. They'll say dot projection expression, and then this is just really a simple string value, just like we see in the documentation here. So let's do price and product name. Now, the nice thing about doing this is that this is actually specifying the order. So I want to start with price and then do product name, or I could say I want the product name first and then the price. So when I'm iterating over these elements, I can get a little bit more deterministic results from my query here. And it actually looks like that is in the reverse. Not sure why that is, but let's do price followed by product name here. It might actually be iterating in the reverse order there. So I guess this is not actually deterministic here, but in this particular case, what we'd probably want to do is just say, all right, give me all the keys. Or actually, we don't even want to iterate over them. What we can do is say for each DynamoDB item, what we can do is say DDB item dot get. We'll say DDB item dot, and then we could say get, and then which particular key do we want to get? So get key value, and then we could pass in a specific key that we want to retrieve, and then retrieve the value that way. So let's say get, and then we could specify a string value like product name, and we'll just pass that in here and say product name is X, and then we'll say dot, we need to unwrap that value, and of course we need to interpret it as a string, so we'll say as a string value. And so we've got option type here, so we need to do option, and then we need to unwrap that value. Then we can do as string, and then finally we can say unwrap from that. And then we'll say price is X. Then we'll do a DynamoDB item get on the price attribute. We'll say as N this time because we know that price is going to be a numeric value in our particular products table. So now we are actually retrieving the attributes from each item in a deterministic fashion in our client-side code here. So now every single time that we iterate over a document, we can see exactly the results that we are getting back. And once again, we can just change some of the attributes or some of the arguments that we're passing into our query. So if we want to omit things that are over $6, we can just say, I want anything under $6 as our upper bound. And so now we're going to omit the item that cost 6.3, and we just get 2 results here. So it's really up to you to use these techniques to do key condition expressions with the partition key and the sort key. You can do expression attribute values to substitute these placeholders into either a filter or your original key condition expression as well. And you can also use this projection expression down here to specify which attributes you actually need to retrieve from each item, since if an item has maybe 100 different attributes, you might only actually need maybe 10 of those attributes to render into your application. So that's how we can use the query operation in DynamoDB. Again, scanning, doing a table scan is something completely separate that uses a lot more of your read and write capacity units in your DynamoDB table. So queries are definitely much more efficient, and it gives you the granular control over what data you're retrieving and how it's being retrieved and where it's being filtered, if it's server side, client side, or what have you. In any case, I hope you learned something new from this video about querying DynamoDB tables using the efficient query operation. Again, we are StratusGrid, so if you're interested in engaging with our software engineering teams, then please check out our website at stratusgrid.com. Go up here, hit the Let's Talk button. Also, if you would, please go to our YouTube channel here. It's called Go Forth and Cloud, and just hit the subscribe button here. Help us to grow this YouTube channel if you enjoyed this content, and hopefully we'll be bringing you a lot more educational videos just like this one. Thanks again for watching, and we'll see you in the next video. Take care.